will the mid semester start?
February.
In February, mid semester?
Okay. Ma'am, I think
Ma'am,
mid sem
December.
is in December and end
Yes,
sem is
ma'am,
in
December.
Oh, it
February.
is, and when it is, I have to check. Actually, when it is written, I think I have shared the examination thing, so.
Yes, ma'am.
The mid semester February or
Ma'am, mid-sem is
December
in
6?
December, ma'am.
Mid-sem December.
Yes, ma'am.
Yes,
And sem is in February.
Yes,
Then,
ma'am. I think 14th December from 14th or 13th.
okay, then that you, if you know, then why you are asking? Because for me, I have not checked actually. Already I have shared, and after that, let me check once.
Ma'am, can you share the syllabus for mid-semester December exam?
I have already told that whatever I'll teach up to the, before the midterm examination, that will be your syllabus. Okay. Mid-semester examination, yes, 6th December to 11th December. Okay.
फिर से बोलिए ना
6 to 11. You just keep in your mind that two of the chapters will come in your exam, minimum two chapters. Thermodynamics and kinetics.
मैम केमिस्ट्री का तो कुछ पर्टिकुलर बुक नहीं है ना?
नहीं ऐसा तो कुछ नहीं, आप लोग को जो दिए हैं वो बुक
ई बुक
एक बुक दिए है ना?
केमिस्ट्री का बुक नहीं मिला मैम।
Yes, ma'am. No, ma'am.
नहीं मिला।
PDF.
किसी को भी नहीं मिला?
तो नहीं भेजा।
ई बुक
नहीं
मैम ई बुक है मैम
तो ई बुक
PDF
तो
है,
मिला
मैम।
है, उसी बुक से पढ़ो।
हाँ वही फिजिकल बुक कोई नहीं है, सिर्फ PDF ही है।
हाँ तो अच्छा, आप एक मेल करो सेंट्रल लाइब्रेरी को, मुझे सीसी में रखे, उन लोग का क्या रिप्लाई है वो देखते हैं।
मैम मेल सब कर दिए ऑलरेडी, कोई रिस्पांस नहीं आया।
ठीक है, मैं आज देखती हूँ अगर बात करके, और मुझे नहीं लग रहा कि किसी भी ग्रुप में मिला होगा।
मैम वो PDF वाला बुक सॉल्व कर लेंगे तो इनफ होगा क्या स्क्रॉल करना के लिए? सर वो PDF वाला बुक सॉल्व कर लेंगे तो वो इनफ होगा स्कोर अच्छा करने के लिए?
I don't know. Diwali holiday Thursday.
कुछ बच्चों को भी बुक्स नहीं मिली।
This Thursday is a holiday. Okay, so today we'll discuss Manta Praishatham. Am I audible properly or the sound is like dominating?
Yes, ma'am, you are audible.
Okay, so today only we have to manage because nowadays getting a worker is also difficult. So now the laboratory has to work because before 2 years we have not worked in the lab. That's why we have to do some modification. So Bhantoff isotherm provides a quantitative relation for free energy change accompanying a chemical reaction.
Maybe you haven't shared the screen.
I have not said.
No, ma'am.
Quantum isotherm provides a quantitative relation for free energy change accompanying a chemical reaction. So already we know that dg is equal to vdp. When dg is equal to vdp?
Constant temperature.
Can I write? Because you know PV is equal to RT. Here.
Ma'am, can you scroll the screen up once, please?
Yes.
Here G naught is constant.
Yes, G naught is the integration constant. Okay. And it is also known as standard free energy change. Okay. So now let us consider A moles of A, B moles of B, L moles of L, and M moles of L. So already we know that
Ma'am,
yes.
ma'am, can you explain this part once again?
See, we know that actually we are trying to get a quantitative relation for free energy change accompanying a chemical reaction. Okay?
Yes, ma'am.
Okay, so that is our interest. So Bantov's isotherm provides a quantitative relation between free energy change in a relation for free energy change in a chemical reaction. So already we know that dg is equal to vdp. So from that, after integration, we got g is equal to g0 RTLN P. So here G is the free energy change, G0 is the standard free energy change, and RT is like other terms have their usual meaning. So in a chemical reaction, so we have to here we will find out the change in free energy in free energy change in this chemical reaction. So we are trying to get the free energy change in this chemical reaction, and we have considered a hypothetical reaction where A moles of A, B moles of B gives L moles of L, m moles of M. So A and B are the reactants, L and M are the products. So the free energy change in this reaction is delta G is equal to the free energy change in case of the products minus the free energy change of the reactants. Any doubt up to this?
No, ma'am. Thank you, ma'am.
So we know that G is equal to G0 plus RTL and P. In that way, we can write L G L plus M G M minus A moles of A, so free energy of A, plus B moles of GP. Any doubt in this step?
No, ma'am.
Okay.
Ma'am, RT ln TL.
Yes, RT L and P. So in that case, for L, like the product is L, so that's why you have written PL. Okay.
Okay, ma'am. Yes, ma'am.
मैम ऊपर वाले स्टेप में RTLNP भी होगा ना?
Which one? TLN?
लास्ट थर्ड स्टेप B G0 B plus RTLNP.
हाँ, RT. Yes, yes. So this is equal to del G0.
Ma'am, that LNQ, ma'am, what is that?
So this one is Q,
Okay, ma'am.
reaction quotient.
Okay.
So that we can write del G. So here we can write, because we have started from del G. So del G is equal to del G0 plus RT ln Q. P we can write QP. So that we can write.
मैम इसको हेल्महोल्ट्ज इक्वेशन भी कहा जाता है.
इसको
यस मैम.
no Bantoff's isotherm. Helmholtz function is your work function A.
मैम बिकॉज 11th के क्लास में मतलब हेल्महोल्ट्ज इक्वेशन में यही इक्वेशन लिखा दिया गया था, इसी कारण मैं बोल रहा था.
तो फिर मुझे नहीं पता.
ओके मैम, थैंक यू.
So these are Bantoff's isotherm. Okay. So del G is equal to del G0 plus RTL and QP, and del G is equal to minus RTL and QP plus RTL and QP is a so both the relations are called Bantoff's isotherms. Is it okay or any doubts? Next we'll discuss Bantoff's isochore.
Ma'am, a review. Ma'am, quick explanation, please.
इसका एक्सप्लेनेशन एक्चुअली हम लोग को ये रिलेशन निकालना था, मतलब फ्री एनर्जी चेंज का free energy change in a chemical, मतलब quantitative relation for free energy change in a chemical reaction. यही हम लोग को चाहिए और इसको रिलेट करके आपको न्यूमेरिकल्स आएगा. ठीक है. इसका फिजिकल मतलब एप्लीकेशन यू आर आस्किंग और व्हाट?
Actually, the equations explanation, that one. Actually.
इक्वेशन का एक्सप्लेनेशन.
No.
एक्चुअली देखो ये तुम्हारा लाइक एक मिनट. Like first of all, we have considered a chemical reaction where A moles of A and B moles of B giving the product L and M. So change in free energy is the free energy of the product minus free energy of the reactant. So G can be written as G product is for both L and M. So that's why we have written G plus M. So L moles of L and M moles of M reacted. So that's why we have presented in this form. Okay.
Yes.
And similarly for the reactant side, the same way we have presented. And we also know that G is equal to G0 plus RTL and P. So in that case, as we L moles is multiplied for the whole terms and G0 plus RTL and P we have written because L is the product. That's why we have written in the like every terms we have written L. Okay, these terms we have not written, but PL and GL is written for the product L. Similarly for M and A and B all are written for the reactant side and the product side. Okay, and just simplify the G0 terms we have kept once. Okay, to make it del G0 and the other terms we have kept as it is. Is it fine after this?
Yes, ma'am.
So next what we did, product minus reactant. So that way we have written del G0 plus, if we'll just simplify the long terms, then it will take this form. RT is a common term for everyone. So when minus sign we have written in the like denominator and the like positive terms we have written here PL and PM. So that we have just simplified that del G0 plus RTLN product divided by reactant, so that is QP because all terms are containing P at constant pressure. Okay.
Yes, ma'am.
So del G is equal to del G0 plus RTLN QP now. So that at equilibrium del G change in free energy is equal to 0. So the equation will take this form del G0 plus RTLN KP. So del G0 will be minus RTLN KP. So that it will put in the previous term here, then that like equation will take this form. Okay. So now we'll discuss Van Top's isochord.
इसमें वांट ऑफ आइसो क्या लिखा हुआ है?
Isochord. No, before Van Top's isochord, I have to teach you Gibbs-Helmholtz equation because here we have to combine Helmholtz equation with Van Top's isotherm. Okay, Van Top's isochord is equal to actually Van Top's isotherm plus Gibbs-Helmholtz equation. So first of all, I have to teach you Gibbs-Helmholtz equation. Here we can determine temperature dependence of equilibrium constant can be obtained by combining Van Tup's isotherm and Helmholtz equation. Okay. So already Van Tup's isotherm we have discussed. So Gibbs-Helmholtz equation first of all we'll discuss. Then only we'll know Van Tup's isochore. So Van Tup's isochore is the combination of Van Tup's isotherm and Gibbs-Helmholtz equation. So first of all we'll know Gibbs-Helmholtz equation. So here Gibbs-Helmholtz equation. So what this equation provides the temperature dependence of free energy. Free energy change.
Ma'am, what is you written Van Top's after each?
Van Tup's isotherm.
Okay, ma'am. Can I write dg is equal to vdp minus sdt? So at constant pressure,
Excuse me, ma'am.
Yes.
Ma'am, the statement considering an isobaric change
Then
in
in
which
which
initial
initial
state
state
is.
is characterized by S1 T1 G1 and final state is S2 T2 G2.
Thank you, ma'am.
Who can say, who can check this derivative that this part is equal to this part? D by dx u by v formula. So in that formula we can come to this point that this is equal to this one. Del by del t of del g by t is equal to this one. Please check it. This is also another form of Gibbs-Helmholtz equation. Please check that del by del t del g by t is equal to del g minus t del by del t del g divided by t square.
Excuse me, ma'am.
Yes,
Now, what have you written before the bracket in that last expression?
it is or.
Okay, ma'am.
Is it okay for everyone or any doubts?
Ma'am, why have we divided t square?
So I told you not to check del by del t del g by t as is equal to this much del g minus t into del by del t del g divided by t square. That I told you to check. Please check that one. That derivative, can you check or not? Please check the derivative. Who got the answer? Any of you got the answer? Who got the answer? Who can prove that? I'll give the student 1 mark extra in the quiz and assignment. Why you people are silent? If I write, you will just copy. That much only. You cannot just check this one is equal to this much. Please try and show me.
मैम वो माइनस इधर तरफ ना होगा मैम
क्या होगा
लग रहा नेगेटिव मैम नेगेटिव है ना होगा ना मैम
What
टर्म
do you
शायद
think?
Ma'am, completed.
How many students could solve this derivative?
I'm done.
Okay, from the student who will submit first, he or she will get 1 mark extra. Because if people are just going to the class and sitting, whatever I'm writing, that you are copying or taking the snapshot, isn't it? You know, there is 30 marks in the hand of the teacher, that is quiz and assignment. Okay, so the day-to-day performance of the students we are also observing.
Excuse me, ma'am.
Yes, Surajita.
Ma'am, I've submitted in the group.
Okay, let me check. Okay, good. So just remind me, at the time of mark sending, I'll give you 1 mark extra. Okay?
Yes, ma'am. Thank you, ma'am.
So this will be a message for other students. Please prepare yourself before coming to the class. And these are not this is not a difficult task. And you can think of these are assignments. When I'm asking the question to the students, they just to prove this one. And another one is x1 is equal to x2 is equal to 0.5 when the entropy of mixing will be high. That is also your assignment. The student who will solve first, he will get the full mark and other student will not get. So if everything I'll write on the board and you will just copy and paste or just you will take the snapshot, that will not work. Something you have to also solve it from your part. Okay, I don't think that today we can solve that Mantop's ISO code. Within 3 minutes we cannot complete that one. So we'll stop the class here. And maybe tomorrow you have a class or not? Are you having any class tomorrow? Chemistry class?
No, ma'am. कोई news नहीं आई.
Then Thursday is a holiday. Then next Friday we'll have a class. Friday we'll have the class and we'll complete Mantop's ISO at that time only. So this Saturday is working day, isn't it? Yes, this Saturday is working day. Okay, Friday, Saturday, both the days we'll have your chemistry class. So, yes, Shwes, do you have any question?
No, ma'am.
Then you have raised your hand.
By mistake.
Okay, no problem, no problem. I just you have any questions. Okay, so students will end the class here only. And in the next class, we'll discuss Bhattap's ISO curve. So that is the combination of Gibbs-Helmholtz equation and Bhattap's isotherm. Okay. So to know the equilibrium constant, how it is depends depends on temperature. So that will check. Okay. Okay then, thank you all for joining the class and please join in time. And few of the students have not joined, only including me 7.